Hello everyone, I am Mahesh DS working as Assistant Professor in Department of Electronics and Communication Engineering at STM Institute of Technology, Ujire. In this session we are discussing about mobility management. Mobility is the fundamental feature of a user entity in wireless cellular network. How flexible the system which supports freedom of movement to user entity decides how mobile the device and how easy to access the network in the geographical area. So how the mobility is managed now? What are the scenarios by which mobility takes place? That will be discussed in particular session. LTE mobility management functions are classified based on two different types. That is, one is the intra-LTE mobility, that is the first category, and other one is the mobility to other systems. So these are the two conditions where mobility takes place. We will see one by one. So intra-LTE mobility. So that is the meaning within the LTE system, if there is a mobility taking place, then it is called as intra-LTE mobility. So it is a mobility within the LTE system. It can happen either over S1 interface or X2 interface. These two are the interfaces which helps for mobility. Else the connectivity may get disconnected or it may be lost during the movement. So any one of the interface should run to continue the connectivity with the network. So mobility through X2 interface occurs when UE moves from one E node B to another E node B within the same RAN attached to the MME. Here the meaning is to know that UE is belonging to a system MME which holds two different E node Bs, source E node B and target E node B, which are belonging to the same MME. If there is a mobility, then that mobility is possible through X2 interface. There is one more type of mobility, that is S1 mobility, where this holds good when the system is linking with another system which is 3GPP type or non 3GPP type. It is other than the LTE system. At this point, S1 comes into picture. The mobility through S1 interface occurs when the UE moves from one E node B to another that belongs to a different RAN attached to different MMEs. That is, source MME and target MME are different. Source E node B and target MME are connected to source MME and target MME respectively. Thus, now the user entity is moving from source E node B to the target E node B. In this case, PDCP context is not continued and the UE need to re-establish session once it moves from the source E node B to the target non-LTE E node B. So let us see what is S1 mobility. It is a protocol again and it contains three different phases, just like how we operate anything. One is the preparation phase, other one is execution phase, and finally the completion phase. So in the preparation phase, once a handover decision is made and identifying target MME, E node B, and the network needs to allocate resources on the target side for handover to happen. So once the decision is made, it identifies the MME through the target E node B and allocation resources and the target sides of the handover is done. Now MME sends the handover request to the target E node B and request for resource allocation to the UE. So it is something like sharing the responsibility, handing over the responsibility of the UE which is seeking the service from the network. Current serving E node B is requesting another E node B to take care of this service and to continue without any glitch. After source allocation at the target E node B, it sends a handover request acknowledgement to MME indicating that okay, I am ready to take the handover. Then after receiving the handover request acknowledgement by the MME, it sends a handover command to UE indicating that okay, UE now you can connect it to source from the source E node B to the next E node B, that is target. This is a pictorial representation of the same operation. Here you can see preparation phase, this is the execution phase, and this is the completion phase. If you go from the top, you can find the network elements like UE, user entity, this is the mobile phone, then you have source E node B, target E node B. From source to target, the device should move, that is user entity is moving or getting connected. Now current serving E node B is linked with the source MME and target E node B is linked with the target MME. Thus now we have two different MMEs to which two different eNode Bs are connected. Now user entity is moving from one eNode B type to other eNode B. Thus it is the other side of the network which is a non-LTE system. Now as per the points what we have observed, handover request is passed to from the source eNode B to the target eNode B. It is also called as target eNode B to MME. So now the first command is handover request from source eNode B to source MME, which takes care of the mobility management, and that in turn forwards the same reallocation request to the target MME to which eNode B is belonging. So which is the eNode B? Now the nearest eNode B, which is considered to be the target, which is having the strongest signal for the service providing. Now upon identifying that target MME gives the command to target eNode B saying like there is a new element, user entity is coming into your geographical area. So that handover request is passed to the target eNode B. Once the received request, it is processed and resource allocation is done. So now here the resource is set up. Next, once the resource is set up, handover request acknowledgement is done saying like the resources are ready for the handover, and from then forwarding the same reallocation response to source MME saying like we are ready to receive the movement of the UE from source eNode B to the new target eNode B. So this is the preparation phase. Continuing with that, in the execution phase we can find now the actual action takes place. Till now the preparation done. Now source MME gives the command to source eNode B for the handover. Handover command is passed, and the same handover command is passed to the user entity saying like the target eNode B is ready to receive the connectivity with the UE. So that in turn the same command is passed to source MME saying like eNode B status transfer. It requires the status of the eNode B so that it can be continued with the same level of operation, else there is a degradation in the performance. So eNode B's status is transferred. Now the target MME receives the status. So MME status transfer is passed to the target eNode B. Now this is exchanged over here. So in the execution phase, again at this point here you can see handover command is passed, and after in network side this operation takes place, that is eNode B status transfer and MME status transfer, and at the eNode B side, sorry, in the UE side, RACH random access channel access process runs. So it searches for the random access channels which are provided by the new cell. So that is eNode B, target eNode B. Once it upon receiving, handover confirmation is sent by UE. So it is now started receiving or getting connected to target eNode B, which has got stronger signals, and it is ready to complete the handover operation. That is notified to the target MME saying like a new member UE has entered eNode B, which is a target eNode B, and the handover notification is done. In the completion phase, you can see the forward reallocation complete is passed. That is a command again to say like okay, from the source side the target has already received the eNode B. Now eNode B is command, and now UE is belonging to target MME. So that command is passed to source MME. In turn, source MME informs the previously serving eNode B, that is a source eNode B, to release the resources. This resource releasing is very important because other UEs will be waiting for the resource allocation. So at the present scenario, the previously allocated resources for UE is not being used, so it has to be released back to the network. The same information is available here with the execution phase. Once UE receives the handover command, it accesses the target eNode B using RACH. Source eNode B initiates the status transfer where the PDCP context of the UE is transferred to the target eNode B. Then source eNode B forwards the data stored in the PDCP buffer to the target eNode B. So that is the status of the device to which the access is provided. So that PDCP buffer information is to be forwarded to target eNode B. Now UE is able to establish the network through the target eNode B and sends the handover confirmation message to the target eNode B. The same is shown over here, again the same diagram. And in the completion phase, when the target inode B receives the handover confirmation message, it sends handover notify message to the MME. Then the MME informs the source inode B. This MME is the source MME, informs the source inode B to release the resources for the next use. So this is the completion phase about the interface. Thank you everyone.